So, if everybody still has this guy open, wow, my fan is going like crazy. So there's another kind of parameter that is special and unique. It's called a reporting parameter. And what a reporting parameter is it is basically a method to poll your model for information. So you can put a reporting parameter in a door family, for instance, that measures the thickness of the wall. So if you put a reporting parameter in a door, and you put the door all over your building, you can ask any one of your doors how thick the wall is that it's put in, which can be useful for people for doing everything from fire ratings to knowing how thick you want your trim to be on any particular wall. There are different levels of strengths of reporting parameters so that they can do different things, and I want to walk through a couple of ways that you can use reporting parameters, and I'm just going to use curtain panels as an example for ways that you can do these things. And what I want to do is I want to actually make a reporting parameter that makes this curtain panel a different thickness based on how big it is, how big the cell is that is put in. So the first thing that we're going to do is, remember how before we saw that using dimensions like everything else belong to the reference plane of something. So if I have my measure tool and I use the set work plane, I can set the work plane of this line, and I can dimension from that point to this point. And why does that matter? Well, if I just set it to level 1, say, and I measure from point to point like that, they're not measuring the same thing, even though they look the same right now. See that? This is actually measuring a shortest distance between these 2 points, and this one is measuring a projection down onto some other level. So it matters where you put those dimensions because they measure different things. So like any other dimension, I can select this and I can add a parameter to it. So I would encourage you guys to follow along. And what I'm going to do is I'm going to call this length, not with capitals. And I'm going to call it an instance parameter because every time that this panel gets put into a cell on that divided surface, it's going to be a different measurement. So it's not like it's going to have the same measurement all around. It's going to have a different measurement for every time it's instantiated. And I'm also going to call it a reporting parameter. And this little blurb says, it can be used to extract value from a geometric condition and report it in a formula or as a schedulable parameter. So this is about taking data from your model and bringing it downstream into the rest of your BIM model. For scheduling purposes, so you want to know how many 10-foot panels I have, or I want to say if my panel is larger than 10 feet, I need it to be thicker so it can hold up itself, or so it can hold up something else. There might be reasons why you want to have that information for downstream use. So I'm going to call it a reporting parameter, right? So what does this mean? If I take this guy and I just make my basic panel out of it again, I can load this into the project that I had it in before, Family 5. And you can see it's now been instantiated. So, big deal, there's nothing there. If I tab into one of these cells, I now actually know how big it is on that one side. I now know that one of these sides is 18 feet and change, right? So this is just the tip of the iceberg for how I can start using a reporting parameter to start polling my model for data. Now, what I can also use that for is making relationships between other pieces of geometry. So if I select this guy, and before we saw that I can make an instance parameter to drive the height, I can do that again. I can call the height that parameter. But now, like we were doing before, I can go in here and I can make my height driven by my reporting parameter. Now you see there's a couple things going on here. Length is grayed out because there's no point in you trying to manipulate it. The reporting parameter is going to do what it's going to do. It is just telling you the state of events of the model. It's not allowing you to drive information back into that parameter. That parameter is just there proclaiming itself all the time. But I can take that same proclamation and I can say, okay, now I want the height of this panel to be length divided by 2. So now it's 6. So I go like this, and there it is. So if I load this back into my dome family, what's that? The height parameter was an instance parameter. The height parameter needs to be an instance parameter because you have an instance parameter. An instance parameter can't drive a type parameter because types happen on everything, and instances only happen on that one. So that would be a conflict of what you're telling things to do. So you can have the reverse. You can have a type parameter that also affects an instance, but you can't have an instance affect a type. I'm never very good at explaining that difference, but Tom, if you have an explanation for that one, it's basically whether or not you're going to have the family that you're loading in overwrite any instance values that you might have already created. It doesn't affect anything that we've done so far. So what we can see now is that we've got changes in this geometry, and I'm actually just going to turn on where's my section boxes? So here, if you look at some of these guys, you can, I'm just going to tab in and isolate a few of these elements to see what's going on. You can see that as they're getting larger in the space that they're being extruded from, the height is getting larger as well. Now, you can set that up as an inverse relationship or a logarithmic relationship or have it based on multiple other relationships, but the basic idea is that you've got one thing that is just listening for a current state of events, and it's passing that information down the line to something else. Now, the next stage of this life cycle, I'm just going to get rid of this one. Is how this sort of information can show up down in your project. So I'm going to reset that. So say I've got this mass family. I'm going to load this into my project. And there's my snazzy little guy. And it has, certain mass properties. Because it's only a surface, it actually doesn't have any volume, so I'm not going to be deriving any information from it. But what it does have is it has all of these panels on it, right? And I can actually tab into these panels, and I can start seeing that information showing up, right? Height and length, those are still in there. And what I can also do is I can make a schedule. And that's over in the view properties. And because a schedule is a table of information of things that are in your model. And because it is showing up as this table, we call it a view. It's another view of your database, essentially. So I'm going to do a new schedule. And when you make a table of data in your model, you need to say, what is it that I'm looking at? Am I looking at walls? Am I looking at multiple things at once? Am I only looking at doors? That sort of thing. Right now, we're going to do a table that's only looking at curtain panels. And it's going to automatically name it panel schedule. So we're just going to leave those defaults there. And it'll give you a bunch of stuff that you can add to this table. there's certain properties that are built into panels that it'll allow you to get. Revit automatically generates what the area is. It'll have information about what family you're looking at and what type it is. Let's just do area and family for now. And then we add those. Okay? We're going to go okay. And now I've got 144 line items for every single panel that is loaded into this project. Actually, so 145 because I've got an extra one in there. And it's just telling me what the square foot is for each one of those and which family it is. If I window tile, that's WT. Oh, actually, I can't WT from there. Hold on. You can WT from here, but you can't WT from the schedule view itself, which is just one of those things. So if I'm looking at my model, I'm just going to look at the top of it here for a second. And I've got all of these panels here. I can actually go through and I can select elements in my schedule and I can see in the model which one I'm picking. And if I go into this table, I can sort how this data comes up. Like maybe I want to see in ascending order for what the biggest and the smallest area of each panel is. So I go to sorting and grouping, and I can say I want to sort this by area. So now these are my smallest panels down here, whoop, right? And if I scroll all the way down here, I can see these are my biggest ones, like that. Now, one of the things that we didn't see available to put into this schedule was exactly those reporting parameters that we just added, right? So if I go into my fields, I don't have available height and length, which is a hassle because we just went through all the trouble of putting that stuff in there. Wouldn't it be nice to have it? There is a thing called a shared parameter. And a shared parameter is a parameter that is available both in the family and in the project. Regular parameters are not available out of the box in the project environment. And there's, I'm sure, a whole long list of reasons for why that is, but it is the state of being in Revit that is the case. So what we need to do is we need to make a parameter that's available to us in the project and that's available to us in the family. And that's what we're going to do right now. And we're going to make a shared parameter. So if I go in here, I can go into my properties here, and I can alter, I can modify these guys, and I can also add new parameters. Well, I'm going to actually end up, in the end, I want to do something that I think is going to be a little bit more useful for us to poll our panel about. I'm going to measure what its deflection is. One of the things that happens with actually building these things is that people make all these goofy geometries and then they try and panel it with curvy panels and then they find that it's very, very expensive, and then the value engineers come in and they make all the panels look bad. So some architects have been trying to get control of that process a little bit by trying to anticipate how buildable their projects are. So one thing that I've seen people wanting to do is trying to find out what the deformation of their panel is. So what we're going to do right now is we're going to create a measurement of deformation of this panel. And we're also going to make a way to measure and see that information back in the project environment. So again, I apologize that we're doing a bunch of stuff at once here, but again, each one of these things is like 40 minutes. We do it separately. So I want to find a way to measure the deformation of this panel. And basically that's how much are each one of these panels out of plane with another. So what we're going to do is I'm going to take each one of these points and select them. And if you use the Spline Through Points tool, it'll connect them. It's just sort of an easy way to connect the dots. So select, and connect the dots. And what I want to do is I want to measure the distance between the intersection of these two planes, because that will give me a good hard number about how much deflection is going on in this panel. And the way I'm going to do that is I'm going to take a reference line, and in fact, you know what, we can just take these lines like this, and we can turn them into reference lines. And then I'm going to make another reference line between them. And, oh, we haven't even covered this yet. Right now with my reference line, I'm just drawing regular old lines and it belongs to whatever plane it's on. I don't want that. I want a line that belongs to these two lines. So what I'm going to do is I'm going to turn on something known as 3D snapping. Here, I'll do that again. So reference line and 3D snapping, checked. Now what this is a line that doesn't belong to reference planes or work planes or levels. It belongs to a couple of points. And oh my God, we haven't even covered point hosting. But this is so compressed. I'm a little jarred by it. So what I'm going to do is I'm going to host one of these points on this guy, and I'm going to host one of these points on this guy. So now, just with a couple clicks, I've actually created a fairly complex set of relationships. I've got a line that, oh, by the way, TL will give you thin lines, which will make all your lines 1 pixel, which is just sometimes easier to see what's going on. I have a line that belongs to these 2 points, and those 2 points belong to these 2 lines. And you can do that actually with points as well. You can host points on that guy. You can select points, and you can pick a new host for them. Move them around. Points are magnificent, and they are unlike points that happen in regular CAD packages, because like anything else in the stuff that we've been talking about, they have properties and they have characteristics. So if you select a point, you can see that it has rotation, it has a directionality, it says how close it is to the thing that it's hosted on. This point has been put on level 1. I can change it to be 10 feet off of level 1, just numerically. I've got a bunch of blog posts on just what you can do with points. So it's a whole other thing. But for now, what we're going to use it for is just to create a controlled relationship between all of these lines. So you can also take these points and you can have them driven by multiple masters. So right now, this point is constrained to this line. It belongs to that line, and it will move with that line. If I select that point, I can also say host point by intersection, which means I want this point to not only be constrained to that line, but I want it to be constrained to a relationship to something else. And that something else I want it to be constrained to is this line. So now this point will not only move only on this line, but it will also only move on that line as it intersects in space with this line. And I can do the same thing with this guy. Host point by intersect, kabam. So now what I've got is I've got a line that is going to precisely measure, or precisely describe, I guess I should say, the intersection point in space between these 2 lines, which is in fact how far this panel is deflected. Everybody good? Excellent. So, now that I have this line, I need to know how long it is, right? Same rules for what we've done before. You get your measurement tool, and you need to say where you're going to be measuring it from. I'm going to be measuring it off of this reference line. I can choose either one of the work planes of this line, but I'm just going to choose that one. And then I'm going to measure from its start to its end. And now I know that this 10-foot panel is deflecting by 2 feet, which is useful for manufacturing or for anything else where you're actually going to want to make this into something. If I had a panel that was deflected only that much out of plane, I might take it to my glass manufacturer and he'd say, that's fine, I can bend it into place. But if I take it to my manufacturer and it's that far out of plane, he's going to say, you need triangles, or you need a lot more money. So now that we have our basic measurement, we can do things with it. Now I'm going to label this, I'm going to add a parameter. And this time I'm not going to do a regular parameter because we see that that doesn't percolate all the way downstream into the BIM, right? what we want to do now is we want to make a shared parameter for this guy. So up here in our properties, we got shared parameters. So it says, can be shared by multiple projects and families, exported to ODBC, and appear in schedules and tags. Great, because that's what we wanted to do. So shared parameters actually create an external file. It's like a little text file that basically just has a list of parameters. And the RVT file is going to open up that same thing and say, oh, these are shared parameters. These are parameters that I can look for and use for schedules. So what we're going to do, I actually already have some. You probably have a blank right now. So if you go to Edit, you can go Create. So ignore all this stuff that I have because I've just got a bunch of shared parameter files in this. You go Create, and somewhere on your computer, make a new text file, and let's call it MIT deflection or something. So now I've got a file that I can create a series of parameters that I know I can assign to things in my family, and I know that they can show up in my project, because I'm going to have my project load the same shared parameters file. And I'm going to say a new group, and let's call this, a new group, and let's call this deflection, because I have no imagination. All right, so now we need to say what our parameters are. So we're going to do deflection, and we're also going to add something that's going to measure a couple of lengths that I'm going to throw in just for good measure. So we're going to go new, and this is going to be another length parameter. You can add numbers, areas, volumes, whatever, but the default is length, which is good because that's what we want. And I'm going to call this midpoint length. All right. And while we're here, I'm also going to make a new one that's called length 1, and another new one that's called length 2. And because I'm in the process of setting this, I want to make sure that I'm going to OK out of this with midpoint length, because that's the parameter that I'm in the process of assigning. So I got midpoint length. And is this a type parameter? No, it is not, because it's going to be different in every single place where it occurs. So I'm going to call it an instance parameter, and I'm going to call it a reporting parameter, like so. So now I've got another parameter. It looks like anything else. It just has a longer name, because I gave it a longer name. And I'm going to do 2 more values here, because it will probably be important about how big this panel is as well. You know, if I have 2 inches of deflection on a 30 by 30 inch panel, it's probably less important than 2-inch deflection on a 1 by 1 panel. So I'm going to add that in here too. So I'm going to go measure, set, and I'm going to choose this diagonal, and I'm going to go from the point to the point, and I'm going to do the same thing on this line. And I'll pause to let everybody catch up, because usually this is a little tricky. Set, I'm going to set the work plane, and I'm going to go point to point. Right? And it doesn't really matter that I did this one on the side, because it's still measuring the same line. So I can select that one, and I can assign it a parameter, right? So I can go add a parameter, and this is going to be another shared parameter. So I'm going to say shared. And I'm going to select it from that list of parameters that I already made. So I remembered this time to record this because I didn't record it earlier. So tomorrow when you go and try and do this, you're going to forget a part of this. And I'm going to make this video available, because doing shared parameters can be like docking a spaceship. It's like you've got 9 different pieces that need to come together at the same place. So I'm going to select this from the list, and we're going to call that length 1. Kind of arbitrary, but... And that's also going to be an instance and a reporting parameter. And I'm going to do length here. And this is going to be another one. We add the parameter, shared parameter, select from a list, length 2, instance, reporting. So tomorrow when you try this again and you're going to forget one of those steps, we'll figure it out. So now we've got this panel that's all tricked out. It's got its midpoint measurement and it's got two length measurements. What it doesn't have right now is any geometry, so it's not even going to show up if we put it in. So I'm just going to select this line and select this line, and I'm just going to create a surface so I can see what's going on when I load this into my project, right? So I'm going to load this into my family. We can also do this where we do this directly into an in-place mass, but we've already got this other family going on, so we'll just go with it.
Why didn't it show a revolve? When you pick two lines now, it didn't show the revolve option.
Why didn't it show a revolve option in that one? Probably because the two lines were not in plane with each other.
Okay, so
Yeah, the lines have, good question, but yeah,
yeah, okay.
it theoretically could make a revolve with lines that aren't in plane, but
because they're not on the side.
yeah. So I'm going to load this into family 1. Suddenly my nice geometry is going to get a lot simpler looking. I'm going to get rid of this one too because I don't need it. So, I can go through here and I can just verify that it's doing what I want it to, right? That I've got my midpoint length is 0, 0 because, in fact, all of these are planar, right? This is one of the fun things about revolutions is that all the panels are going to be planar, which is boring. So let's make these non-planar panels so that they're actually something interesting to look at. So I'm going to take my grid, and I've just selected it. There's a property here called all grid rotation. Now if I turn this into 45, I can rotate all of my panels, and it'll take a second to regenerate it. So now I've got all these panels which are not planar. And how do I know that? Well, I can look at my deflection measurement. And I can see that the midpoint length is 2 inches at this one. And if I go into this guy, I can see that this one is off the charts at 1'3" out of plane. So already I can start looking at my model and getting real hard data out of it about what it is. Get it to my manufacturer, say, how do you feel about 3 inches out of plane? And then he can charge you lots of money. So now I've got this thing. I can load this into my project. Can overwrite my existing guy. So here's an interesting thing. We changed something that is nested into the family that we're loading in, right? And so now the curtain panel already exists in the project. And now what it's asking is, I already have a curtain panel in here called family 5. Do you want me to override this one, or do you want to use the existing one? Well, we just tricked out this panel number family 5, so we want to override it, and we want to use the new one. So overwrite the shared subcomponent family and its parameter values with family 5 version. Yes. And we see our cool geometry get reduced down to something that's relatively stupid looking. But data rich. It really is. Like, if you get into your left front pocket with your right hand over your back, does your elbow hurt? Yes. All right, so now I've got my thing. As before, I can tab into this. I can look at the data that's in here. So I got these things which are now extraneous because I took them out. We probably should have deleted them, length and height. But we've also got length 1, length 2, and midpoint length, right? Now, up in Manage, there is something called shared parameters. This is where we make sure that the project is actually looking at that shared parameter file that we had. We had that text file that says, here are 3 parameters. I want to make sure that everybody has access to these parameters. So if you click shared parameters, you've probably already got it automatically set up where it said, okay, we're all on the same page. We've got the same thing. Does everybody have this? Their shared parameter is now available to them? Yes. So now what I can do is I can go back to my schedule, panel schedule.
Can we recreate that? Because I
You want to?
schedule.
Sure. Let's create a new one. Doesn't hurt to repeat this. I'm actually just going to delete it so that it doesn't get confusing. Like that. So view, schedules, schedule quantities. These are a bunch of other ways that you can also create tabular data. And this stuff is available for export to .txt files, so you can bring it into Excel. You can do other things with it. This is where you can schedule things like, I want to know how many square feet of wall paint number 5 I have. You know, how much sea breeze am I putting on my walls? Anything else, or how much concrete is here? So schedules and quantities, curtain panels. Okay. Now, we've got a couple of new parameters here, right? So we're going to go, let's go back in and let's say, let's just get our length and our length 2 and our midpoint length, which are the parameters that we created in the shared parameter file and are now available to us.
One question, can we get a new formula here? Let's say the proportion of the, whatever, mid-length.
I'm glad you asked that. This is like a softball. Yes.
Okay.
So, calculate value.
Yeah.
So, we've just added length 1, length 2, and midpoint. And we decided that that deflection measurement might not be all that important unless you have it in the context of how big that individual panel is, right? Essentially what we want is we want to get like a percentage deflection for that panel. So what we can do is we can calculate a value that's going to show up in our schedule. So I'm going to hit calculated value, and it's going to be a number. Because it's going to, don't be distracted by percentage, because it's sort of something, we're going to end up with a percentage, but it has nothing to do with this. So we're going to call this deflection percentage, and it's going to be a number as opposed to a length or an area or a volume. And we can just start defining this. So we say, I want my midpoint length, or you can actually just type this in. This just saves you from doing fat finger key mistakes and putting in the wrong value. By the way, also, this is case sensitive. If you do go in and you type this stuff in, you have to make sure that all your cases are correct. So we can take midpoint length and we can divide it by, actually how would we do this? We'd probably do parentheses, length 1, plus, and we can just do length 2, divided by 2, and that whole thing would be times 100 if we want to get a percentage. Anyway, you can sculpt this formula however you want, and then OK out of it, and now you have a deflection percentage, which is also a field that's going to show up in your schedule. Good? All right, so now we have this nice schedule, which has length of each one of our guys, the deflection, and an overall percentage of it. So if we go back to here, we can window tab, and I just want to look at this guy now, so I can stretch around my windows like that. I can look at it from the top, and now I can just sort of start verifying this stuff. So I've got all these midpoint lengths, and again, I can tab through here and I can see which one is which. Say I want to see, okay, where are my expensive ones? So my expensive panels are going to be the ones that have the highest deflection percentage. So if I look at my deflection percentage, I go all the way from 0.07% deflection all the way to 1.25 deflection, which presumably is going to be a bit pricier. And I can also see which ones those are. And sure enough, those are the ones that look pretty caved out. And I think as I go up here, you're going to see, as I get less and less, it's going to get closer and closer to the middle, where there's less of a percentage of deflection over the course of this whole thing. For the most part, this is as far as you'll ever really need to get. However, we are architects and we like visual data. So you might want to represent this stuff visually to actually see which ones are flat and which ones are not relative to each other, right? There's one other way to mine data out of here that is useful. And before I forget, I just want to show you this one thing. If you go to export, whoops, that's not what I wanted. Sorry. If you're back here in your schedule and you go to export, you can export a report. It's like our naming conventions are really weird. It's like, is it a table? Is it a schedule? Is it a quantity? Is it a report? Here it's a report. So you're going to export a report, which is going to be your schedule, and you're going to export your panel schedule. And this will just be, you can say it's tab delimited, and then you can go and do whatever you want with that data. You can bring it into Excel, munge the data, whatever you want. And there are ways to actually set this up bidirectionally with a database through third-party applications. There's a tool called Excel Link, which is available for 50 or 100 bucks. You guys could probably make a deal with the guys to get a copy of it if you're interested in this, where it'll establish a link with an external database and you can move back and forth with values. There's one for subscription customers, which depending on what MIT's relationship is with Autodesk, you guys would have access to it, which is you can set up a database relationship with Access to do more advanced calculations. But if you just, what's that?
What was that one called?
It's called RDB Link. It's Revit Database Link. And that's a subscription item, and then the other one is Excel Link. There's probably a bunch of other ones. There's also examples in the SDK for creating Excel spreadsheets or reading Excel spreadsheets back in. It's a kind of a common thing that people like to do, and there's a couple of examples in there. Lots of great ways to mine your data because, like I said, this is essentially a database that has a 3D front end on it. So you can get its data in a bunch of ways. I don't program and I don't do any of that stuff, so I do this all entirely through the UI. So sort of why I play around with this stuff. So we wanted to see our deflection as represented here, visually. So this is going to use something that's called filters. Everything in Revit has a category. And if you go to views, you'll see something called visibility graphics. Visibility graphics is not the same as, but often used very similarly to how levels are used or layers are used in CAD applications, where you can turn on and off the visibility of different things. Here, what we've got is we've got a list of every kind of category that's in the project or available to be in the project, and the ability to turn on and off its visibility. So right now, what I pretty much have in here is I have my panels, and if I go to my curtain panels, I can turn off their visibility here and apply that, and they disappear, which is not really useful for me, but that's what it does. It turns on and off that visibility. I can also override. Actually, we're in a hidden line view also here, so I'm just going to jump out of here for a second to show you this. There's shaded views, realistic views. There's different ways to view your model. If you do shaded, it's going to actually just sort of shade all the surfaces, as you might expect. And just to go back out to visibility graphics, you can override how this thing appears in the view through visibility graphics. So I can say curtain panels, I want all my curtain panels to be patterned with an override in this view. No other views, just this view. So I'm going to say I want them all to be hot pink and cross-hatched, because that's how I roll. And if I go apply, wait, if I go OK, wait a second, why is it not doing it? Ah, there we go. So now I've got cross-hatched, pinked overrides in this view. If I make another view, or if I look at it in my site plan, you don't see that. That's something that's called a view-specific override. Every view can be customized basically is a different way of looking at your model. So I just did a view-specific override for my panels so that they have this pattern on them. Well, I can use that same kind of functionality to selectively color things. So I'm going to turn this off. I'm going to say no override, and I'm going to go back to no override, so everything's back to normal. But I want to selectively look at this model with that same kind of functionality to identify pieces and color them in a particular way. And what I want to do is I want to see how many of these panels are with less deflection than 2 inches. Well, I want to see how many of them have more deflection than 3 inches, or something like that. Well, I can do that using filters. So here are my filters, of which I have none right now. And I can add a new filter. I can also go directly to filters, not through visibility graphics, but through this filters button. And this is how you start defining how you want to start selectively viewing things in your model. So I'm going to edit, and I'm going to add a new one. And if I do a new one like that, I can go, I'm going to call this deflection 1. And right now it has no categories defined. But what I want to do is I want to specify that I'm going to filter out, and I want to look at curtain panels. So I'm just going to look at curtain panels. And now, because I'm looking at curtain panels, I want to look at, and this is the thing where I always have to figure out why it's not showing it. Filter rules. Okay. So my filters are not yet showing up with all of my parameters that I want. It's showing up basically a bunch of built-in parameters, and I need to add those shared parameters again. Shared parameters are kind of a hassle in that way. Sometimes you have to keep reminding it to look for different things. So I want to filter by a certain parameter, and I need to get that parameter. Parameters that are available in this project, I want to add my shared parameters. And I'm going to add it for curtain panels. This is where we really get into the docking a spaceship thing, where you need to make sure that like all of these pieces are working together. So I'm going to select my shared parameters. I want to select midpoint length. I'm just going to grab that one, because that's the only one I'm really concerned about at the moment. I'm going to say midpoint length, and now I have midpoint length available for my rules. All right, so now I have midpoint length. And I can set up a bunch of rules for how I want it to appear and why and when. I want, for anything in this view that is a curtain panel that has the parameter midpoint length that is less than 2 inches, let's say. I'm not sure what the range is on these guys, but let's try 2 inches. So that's all I'm looking for. All right, so now I have a filter set up in my visibility graphics for deflection, and it's only for panels that have a 2-inch midpoint measurement. If I turn off my visibility here, no, they're all under 2 inches. Is that right? I guess it is. Did I? Hold on a second. Let's see that. So if I tab into these guys.
Did you do any type of override yet?
What's that? No, I didn't do an override yet because I'm just sort of making sure that my range is correct. Let's see. 6 inches. 1 foot. Did I put in 2 feet? Nah, I put it in at 2 feet. My mistake. Sorry. So 2 inches. So back in visibility graphics, in filters, let's see which guys are less than 2 inches. I can just say, just turn off anything that isn't, turn off anything that fits my rules as defined in the filter. So these guys have now disappeared because they have less deflection than 2 inches. Right? So I can also do more interesting things with that, like I want them all to appear blue. And I want them all to be patterned solid so I can see them all nice and solid blue. Apply that. So now I can see those are my cheap panels. My cheap panels are in blue. So now you can go through and you can just make this as fine-grained as you want. So I can duplicate that one. I have deflection 2. Now let's say is less than 4 inches. Nope, 4 feet. Again, fat fingering this. And midpoint length is greater than or equal to, what was my other one? 2 inches. So now I have something that makes a distinction between these guys. So now I can add that one in, deflection 2. And so the next step up is I can make one that is showing as seafoam with a solid pattern. Anything that is between 2 inches and 4 inches, which is nothing. Is that possible? 2 inches and 4 inches. What's that? I had model in the window. Ah, thank you. Somebody's paying attention. Yeah. A lot of places you can shoot yourself in the foot. There! So these are all the panels that have a deflection between 2 inches and 8 inches. So as you build this up, you can add more and more of these layers so you can just keep going through. So now that you've got it working, you can start making this more fine-grained. So I'm just going to do 4 inches. And now I'm just going to start copying this. Deflection 3 is going to be, let's say this is between, 2 is between 4 and 2, then 3 can be between, is less than 4, is greater than 4, and less than 8. And now I can copy that again. I can do, this one is greater than 8, less than 10. Anyway, and so on. And so what you can do is you can start building up your graphical display to start mining data out of this. So I'm going to add all of these guys back in and just start colorizing my model based on its deflection. Let's see what we get. As you build it up. So now this is, again, this is like the, once you want to get out of the tabular data into something that's actually going to represent in your model, you can get that sort of thing. So what this allows you to do then is you actually now have a fairly generic way that you can start sculpting tools to start interrogating your model on the fly. If you go now, I'm going to make a new component. Oops, not place a component. Sorry. I'm going to new model in place. And I'm just going to do something right here that's going to use these same tools because I've already set it up. I'm going to make some sort of generic curvy form. And I can immediately start finding out how much deformation it has. So this is all the stuff that we just learned before. I'm going to divide my surface. I'm going to make it something chunkier. I'm going to panelize it with my special panel that has all that information embedded in it. And I already have feedback on how deformed it is. So now I can see that you know, these panels are more expensive than these panels. And I can start doing things like, if I go back into the basic form, I can start changing how this guy is set up to sort of see what effects it's going to have on deformation. So if I change that shape, it's going to percolate through my forms. It's going to give me a real-time feedback on deformation based on its color. So now I know that all of these panels lie within the range of blue and green. And those things are also now all showing up on my schedule. Pardon me? What was the button for the deformation? Well, that was basically the whole, the filters are what's going to give us the color. So, is that your question? Sorry, I don't understand the question. Mm-hmm. Right, because yeah, sorry, this is the payoff for this, and I'm underselling it. So if I'm in here, if I'm editing this thing in place, say I make my form like this, I can see from the coloration that the way that these panels are deflecting, that there isn't any deflection that is worse than whatever it is that we defined for green, which was, I think, 8 inches. If I go and I select that top curve of my form and I make it more bent, it means that things are going to get more deflected. How much more deflected? I'm not sure, but I can tell from my panels. So if I grab that guy and I make it like this, that just means that it's going to be a much more torqued form. So when I do that, you can see that suddenly I don't have anything that is within that green range anymore, and I don't have anything that's even in the blue range. That is, all of my panels are deflected way past 2 inches, and I'd have to fill out my filters a little bit more to sort of get an idea of the real range. But basically, now I can actually manipulate my model and get real-time feedback on the quality of the panels. So, you know, you can set this same thing up for whatever quality of your model is interesting to you or that you need to look at. You know, maybe it's that I need to make sure that none of the lengths of any of my panel are longer than 6 feet. Because once I make it more than 6 feet, the price per panel goes through the roof. And so you can just make that one of the qualities of your filter in the same way that we set this one up. And then you can manipulate your thing real time and decide which one is going to be the best outcome for you. So basically this is just a way to sort of, in a general way, this is a way to sort of set up analysis or customized analysis models that can tell you information about what you're designing while you're designing it. Yes?
For example, that form case, is there any way we can get a kind of, not just study all these ideas, but maybe drawings?
You mean to unfold it onto all those little pieces? Yes and no. Mostly no. We don't actually have the unfolding stuff. Yes, you can do that through the API. You could make something that goes in and actually reconstructs your panels and unfolds them because all the data is there. For instance, we added reporting parameters that tell you how long each edge is. You could put in measurements to say what the length of each edge is and the angular condition between each one of them, and have an API that goes in and unfolds each one of those pieces and lays it out. I've got a blog post for how to do that through using a lot of the same tools that we've just shown. It's actually here. So this is just a workflow where I'm showing how you can use certain geometric operations to place panels into those cells and then create another representation of those panels someplace else. There isn't an unfold button. There is some heavy lifting that you can do. So here, this video walks through creating a panel that, when it is placed in that divided surface, it will recreate another representation of itself over here that is a flattened version of itself. In general, I would really encourage anybody who wants to get into making custom tools through the regular Revit interface to take a look at this page. There's a guy that you might be familiar with, Robert Woodbury, who has a book called Parametric Pattern. Elements of Parametric Design. What's that? Yes. Yes. And what he's doing is he looks at basically different methods of doing parametric design, where you're not creating geometry directly, you're creating sets of rules and relationships. And out of these rules and relationships are coming your geometry. And there's certain reusable methods that you can use to do this sort of design. His argument is that this is the way that people have been doing design since people were doing design, and that computers are just enabling us to do this. He sets out these 12 or 14 reusable methods that, if you can get your head around these different methods, you can apply it over and over and over again to many, many different kinds of projects. The thing that we just went through with the filters and the color representation, I would loosely call one of the patterns that he calls reporting, possibly the one that he calls selection. But it's sort of generic ways of thinking about looking at your model and extracting information from it. He uses generative components and sort of a pseudocode to do examples of how to do this sort of design. If you are familiar with Grasshopper, there's another guy who picked up on these same patterns and he reproduced them all in Grasshopper. So now we've got the generative components one, which is mostly code, how you can write code that does these different methods. And then we've got the visual programming version in Grasshopper, where they did the same patterns in Grasshopper. So what I did on this blog, and it's an unfolding project still, is doing the same things that they did in Grasshopper and generative components through Revit, through the UI with no coding. So it's trying to sort of be a bit of a Rosetta Stone between these different methodologies, so that depending on what platform you're working in or how you want to work, you can address the same body of knowledge in sort of a generic way of looking at parametric design. There is. Well, the Revit API is sort of a fully developed application level programming environment that allows you to write your own plugins. It isn't a scripting interface. It's really more of a full-blown development environment. There are a couple ways that you can get into doing more scripted work with the Revit environment. In particular, there's one that's called Revit Python Shell, which if you are more into scripting, it might be a nicer way to enter it, and it uses Python, or Iron Python really, to basically do a more direct back and forth iterative process with Revit's API. And there's links to it on this blog as well. Revit Python. Yeah, so the basic idea is you can have your scripting interface and have it running on demand to create geometry or analyze geometry or do whatever you can through the regular Revit API, but through a more immediate feedback loop. And if you are interested in that, I really would encourage you to check out a couple of those posts about where you can get this stuff, how you can hook it up. This is a freely available plugin, the Revit Python tool. Basically, you need to have, I think, just Iron Python installed on your machine as well as Revit.